Next lesson here, we're going to compute with significant digits. Significant digits, what you need to remember about that is significant digits will represent a physical measurement. So when something has a physical measurement such as centimeters, inches, miles, those are physical measurements. You can actually measure that distance. So what we're going to do is we're going to compute with significant digits, and there's 5 ways to do so. Here are your 5 rules. The rule number 1 says non-zero digits are always significant. So the example they give us is 34.5. That has 3 significant digits. All digits here are non-zero, so it has 3 significant digits. Example 2, zeros to the left of another digit are not significant. So notice the 0 here, the decimal point, the 0 there, they are not significant digits, leaving you with only 1 significant digit, that is the 5. Third example, zeros between a non-zero. So for instance, you have 2007, like a year. All of these are considered significant digits. Reason being is you have a non-zero, and zeros in between. So this would give you 4 significant digits. Rule number 4, zeros at the end of a number and to the right of a decimal point are always significant. So the ones that come after this decimal point, that are after a number, there's 2. The ones following that, all those zeros, they are considered significant. So in this part, the 1 would be significant, the 2 is significant, and the 3, giving you 3 significant digits. 5. Zeros at the end of a number, but to the left of a decimal point are not significant. So an example here. Here's normally where your decimal point is. Okay, 7 and 7 are significant. These numbers that come after and to the left of the decimal point are not considered significant digits. So this number 770,000 or 7,700 has 2 significant digits. Note the difference between Rule 5 and Rule 3. Rule 5 and Rule 3. Remember, 2007 is because these zeros are in between 2 significant. When they come at the end and it's to the left of the decimal point, they are not considered significant. Keeping in mind those 5 rules that you have listed above on your paper, you're going to determine if these numbers here are significant. So 1.499 times 10 to the 7th power. These are all non-zero numbers. So they're all non-zero numbers, therefore they are all significant. So this has 4 significant digits according to rule number 1 on your sheet of paper. So if you look back at Rule 1, Rule 1 is talking about how all these non-zero digits are significant. In that first example, all of them are non-zero numbers, the 1, 4, 9, and 9, giving us 4 significant digits. So Rule 1. Example 2 talks about rule number 5. This is the decimal point. This is a significant digit. These zeros to the left of the decimal point are not significant, and they're not between 2 non-zero numbers. So this has 1 significant digit, and this would be according to rule number 5. Example 3, this would be another case. You'd have non-zero numbers here, the 4 and the 5. They're non-zero, so there's 2 digits. This has 2 significant digits, and that would be according to rule number 1 again, the non-zeros. 0.0806, these zeros on the left, they're all zeros to the left. Those are not significant digits. So we have the 8, 0, and 6 would be significant digits because this 0 is in between 2 non-zero numbers. So this has 3 significant digits, and this would be according to rule number 2. If you looked back at rule number 2, rule number 2 talking about zeros to the left So zeros on the left over here, those zeros are not significant, and that's how they had only one significant digit here in that example. Next four examples that we have. In example 5, if you look at it, that's in scientific notation. Right here we only have one non-zero number, so this has one significant digit, and this would be, again, rule number 1. It talks about non-zero. Example 6 is a great question. This is actually combining two rules here. Okay, remember, all these zeros on the left, there's no other non-zero number out here, so all these zeros would be considered non-significant, leaving you with, actually in this case, 3 significant digits. The reason why it has 3 significant digits is because of rule 2 and 4. Okay, rule 2 and 4 help us solve this problem. So if we look back at rule 2, rule 2 again is talking about these zeros on the left, and I believe the problem here was 0.000300. So all of these numbers on the left would be considered not significant. And if we check out rule number 4, it says zeros at the end of a number and to the right of a decimal point. There's the decimal point. So these zeros at the end and to the right of the decimal point are considered significant. So in example 4, they give you a 1, a 2, and this 0 to the right of this decimal point is at the end, so it's considered significant. That's how they came up with 3. This is also how we came up with 3. The non-zero and these zeros after and to the right of the decimal point. Example 7. Example 7 also has 2 significant digits. You have this non-zero, and again, here's our decimal point. Here's the 0 to the right, the one that comes at the end. The 0 comes at the end, so it is significant. This has 2 significant digits. Again, this would be rule number 4, talking about the zeros at the right side of your decimal place that come at the end following the significant digit 7. In example 6, reminder, we had these were not because there was no significant digit in front of it, and we had the 3, which was our first significant digit, and then these zeros following the right of the decimal point. 8. 8 is the exact same thing. It's going to be rule number 4 here. The reason why is this is not significant there, but the 4 and the 9 are non-zero, and this 0 comes at the end following the significant digits, and it's to the right of the decimal point. So this has 3 significant digits. Again, we would state that this would be pertaining to rule 4 that we figured it out. We also tie multiplying and dividing with scientific notation in on this. Our multiplication rule is right here. To multiply numbers in scientific notation, multiply the numbers, and then you're going to add the exponents of 10. So example 1, you have 2 in scientific notation. It says that you'll multiply the numbers here first. So I group those together. Next, I'm going to go ahead and do my powers of 10. And we need to add those exponents because multiplication is happening. Same base, add exponents. So I'll add the negative 5 here. Now I can go ahead and work down my paper and solve. Multiplying my numbers together, we have 9.407 times 10 to the, well, we'll add these powers. Negative 6 plus negative 5 is negative 11. This answer still is not in scientific notation because this number here that we have is at least 1 and less than 10. So there it is in scientific notation. Why don't you try to set 2 up pretty similar to example 1? So go ahead and take these 2 numbers and multiply them together first. and then try with your exponents and check back in here in a second. So we grouped our numbers together. Next thing we'll do is group the exponents. Should look something like that on your paper. Work down the paper, do your multiplication. 1.9 times 2 gives us 3.8. And we add the powers of 10 because this is, again, multiplying. Everything is multiplying. When you multiply, you add those exponents when they have the same base, giving you 10 to the first power. Moving on to division with scientific notation. Well, to divide the numbers in scientific notation, very similar to multiplying. Only difference, to divide the numbers, instead of multiplying, you're going to divide those numbers first, and then the powers of 10, when you have the powers of 10, you'll subtract those exponents because you're dividing. That's the quotient of powers rule. So again, I'd start it up or set it up pretty similar to multiplication. Take care of this here. We have 7.8 times 10 to the 4th divided by 8 times 10 to the 1st. Take those two numbers there, 7.8, we'll group those first. We're taking the 7.8 and we are dividing by 8. Take my powers, or my exponents, powers of 10, 10 to the 4th and 10 to the 1st. 10 to the 4th, this is dividing, same base, subtract your exponents. Numerator, subtract denominator, so 4 take away the 1, parenthesis, work down the paper here. 7.8 divided by 8 gives you 0.975 times 10 to the 3rd power after I subtract my exponents. One problem with this answer here, notice that this here is not in scientific notation. That number is not 1. It is less than 10, but it's not 1. So we need to put it into scientific notation. So here's the easiest way that I think to do this. Take this number and put it into scientific notation. Well, you'd move the decimal spot one spot, giving you 9.75, right? Well, when you move the decimal spot to the right, it's times 10 to the some power, right? Well, you need to figure out, is it to the first power or to the negative first power, because you moved it one spot. Well, when I move it, I need to get it back to this form here. So how can I take this answer and get it back to this form? I would have to move this to the left. So if I move it to the left, it's really going to be to the negative first power. Now, you're still not finished. Basically what you did here is you took this here and put it into scientific notation. You still have this times 10 to the 3rd power. Well, times 10 to the 3rd power. Think about this one here. Same base, multiply, add those exponents. So you will have 9.75 times 10, and you'd have negative 1 plus 3. Add the exponents. We get 9.75 times 10 to the 2nd power. Easy way to double check here is actually after you do your computation up here and you get this answer. 10 to the 3rd power says you'd move your decimal point 3 to the right, so you'd move it 1, 2, 3. This would give you 975. Well, down below, in scientific notation, you have 9.75 times 10 to the 2nd. You'd move it 2 spots, 1, 2 spots. This would also give you 975. So a way to double check yourself, those should come out to be the same. Example 2, why don't you go ahead and give it a shot real quick. Remember, you're dividing here, and then we'll check back in here. So pause the video and give it a shot. First, you should have grouped your whole numbers there together and divided them. Next, I grouped my powers of 10, and it had the same base. So I took negative 1 minus negative 2. Should have done your computation. 2.04 divided by 2 gives you 1.02. Times 10, do your computation over here. Minus minus, well, that would give us a big plus, so negative 1 plus 2 would give us a positive 1. There we have it, and look here. This is in scientific notation. That number is at least 1 and less than 10, so we don't need to do any of the other stuff that we did there in example 3. This will conclude your lesson, significant digits with multiplying and dividing scientific notation.